I am Kyasis of EC department studying second year of 4th sem. Now I would like to talk about my TED Talk topic of subject electromagnetic waves and transmission lines. And the topic is nano electrostatic discharge. Introduction to nano electrostatic discharge. Nano electrostatic discharge refers to the transfer of electric charge at nanoscale level. This phenomenon can occur in various materials, particularly in semiconductors and nanostructures. Understanding nano ESD is critical for ensuring the reliability of nanotechnology applications. This is the introduction to nano electrostatic discharge. Now moving to the basics of electrostatic discharge. Electrostatic discharge is the sudden flow of electricity between two charged objects. It typically occurs when there is a buildup of static electricity due to friction or contact. ESD can cause damage to electronic components, which is a significant concern in nanotechnology. Here we can see how the electrostatic discharge takes place in our surroundings. Now moving on to the importance of nano ESD studies. The miniaturization of electronic components increasing susceptibility to ESD events. Nano ESD events can lead to catastrophic failure in sensitive nano devices. Research in this area aims to develop better protection methods against ESD. This is the importance of nano ESD studies. Now we would know about mechanism of nano ESD. Nano ESD can occur through various mechanisms including dielectric breakdown and charge injection. At the nanoscale, the electric fields can be substantially higher, leading to faster discharge events. Understanding these mechanisms is essential for designing ESD resistant materials. This is the mechanism of nano ESD. Now we would like to know about measurement techniques. Advanced techniques are necessary to measure ESD events at the nanoscale. Methods such as atomic force microscopy, AFM, and scanning tunneling microscopy (STM) are commonly used. Accurate measurements helps in understanding the dynamics of nano ESD phenomena. Moving on to effects of nano ESD on materials. Nano ESD can lead to physical and electrical damages in materials. Common effects including melting, cracking, and changes in electrical conductivity. These changes can significantly affect the performance of nano devices. These are the effects of nano ESD on materials. Here we can see the nanomaterials which are 0-dimensional, 1-dimensional, 2-dimensional and 3-dimensional. In 0-dimensional we can see nanoparticles and fullerenes. And in one we can see nanotubes and nanohorns. And in 2-dimensional nanosheets and nanolayers. And in 3-dimensional nanowire arrays and nanotube arrays. These are the effects of nano ESD on materials. Now moving on to ESD production strategies. To, to mitigate the effects of nano ESD, various protection strategies are implemented. Techniques include using ESD protective packaging and designing robust circuit layers. The development of new materials can withstand ESD is also a focus area. These are the strategies of ESD protection. Now moving on to the role of nanomaterials in ESD. Nanomaterials can offer enhanced properties for ESD protection applications. Conductive polymers and carbon nanotubes have shown promise in ESD shielding. The unique characteristics of nanomaterials can lead to innovative solutions for ESD challenges. This is the role of nanomaterials in ESD. Now we would like to know about the impact of environmental factors. The environmental factors such as humidity, temperatures can influence ESD occurrences. High humidity levels can reduce static charge buildup while low humidity can exacerbate it. Understanding these factors is crucial for redesigning an ESD resistant environments. Here we can see the access to technology, geographical location, environmental factors, access to health services. Now case studies in nano EST. Various case studies illustrate the impact of nano EST. The semiconductor industry has faced significant challenges due to EST events. From learning, these case studies will help to improve designs and protective measures. Now here comes to future research directions. Future research in nano EST will focus on advancement materials and measurement techniques. There is a growth interest in developing nanostructured devices that can self-repair post-EST. Collaborations between academia and industry will be essential for progress. These are the future research directions in which nano EST will focus on advanced materials and measurement techniques. There is a growing interest in developing nanostructured devices that can self-repair and post-EST. Collaborations between academia and industry will be essential for their progress. Now here comes about the regulatory standards for EST. Various regulatory standards exist to guide ESD prevention in electronic products. Organizations such as International Electrotechnical Commission, also known as IEC, provide guidelines. Compliance with these standards is critical for product reliability and safety. The regulatory standards for ESD varies standards exist due to guide ESD prevention in electronic products, such as organizations of International Electrotechnical Commission provide guidelines. These are the regulatory standards for ESD. Now moving on to the conclusion of today's topic, nanoelectrostatic discharge is a significant concern in the development of nanotechnology. Understanding its mechanisms and impacts is crucial for the advancement of electronic devices. Ongoing research will continue to enhance ESD management strategies in the nanoscale domain. Now we will like to recall the topics and the points of today's topic. Nanoelectrostatic discharge is a significant concern in the development of nanotechnology, and we also understood its mechanism and how it can be observed and implemented in our surroundings, and the mechanisms and impacts it creates, and the impacts is crucial for advancement of electronic devices. Ongoing research will continue to give us more information which is will be very interesting and to enhance ESD management strategies in the nanoscale domain. The nanoelectrostatic discharge, understanding its mechanisms, the advancement of electronic devices, management strategies are very important to know about it. And the nanoelectrostatic discharge development of it and crucial for the advancement of electronic. Ongoing research will continue to enhance ESD management strategies in the nanoscale domain. Its mechanisms and impacts, the concern in the development of nanotechnology, it's a significant concern. Understanding its mechanisms and the development and advancement of electronic devices will continue to enhance ESD management strategies is a significant concern. So this is about the topic nanoelectrostatic discharge, which is a significant concern in the development of nanotechnology. Understanding its mechanisms and impacts is crucial for advancement of electrostatic devices. Ongoing research will continue to enhance ESD management strategies in the nanoscale domain. Now here comes about the references of the topic. Smith J. 2022 Nanoelectrostatic Discharge Challenges and Solutions Journal of Nanotechnology. Brown L. 2023 Understanding ESD in Nanoscale Device IEEE Transactions on Electron Devices. International Electrotechnical Commission 2023 Standards for ESD Protection IEC Organization. So these are the references took in order to make this PPT and to know about the nanotechnology and the nanoelectrostatic discharge. These are the references which are taken from IEEE and many online sites in order to gather this information of nanotechnology and nanoelectrostatic discharge. Thank you.